Dear 10th and 9th class students, today we are starting the chapter probability, the introduction part and problems part almost same, particularly in this chapter problems and introduction part is same for both 9th and 10th classes. So here please follow my introduction carefully. So now the term probability relating to chance of raining, chance of my going, chance of passing the examination, etc. In various situations, we use the word chance. So, in which sense we use the word chance in our regular day life? In the same sense, the word probability is taken mathematically. So scientific word for chance is probability. Understood? So, here now you need to discuss some definitions. First and foremost, you have to discuss about random experiment. So, what is random experiment? I'll explain. First and foremost, you should be able to repeat the experiment any number of times. Okay? So, an experiment that can be repeated any number of times. Right? Number 2. Though repeated any number of times, okay, the result is uncertain. So you should not be able to tell the result. Though you have repeated for 10,000 times the same experiment, in the 10,000 plus 1th time the result should be uncertain. So the result is uncertain. But all the results of the experiment should be known. All the outcomes, results, whatever the word may use, all possible outcomes of the experiment must be known. Possible experiments must be known. Possible outcomes must be known. So, an experiment is said to be random experiment if you can repeat any number of times. The result is uncertain though repeated, and all possible outcomes must be known for you well in advance. So that means if you perform that experiment, what are the possible outcomes that you are going to get, that should be known. So if these 3 physical conditions are satisfied in an experiment, it is called random experiment. Throughout this chapter, we use random experiment only. Okay? Experiment means in probability it is random experiment. Next, after random experiment, our next definition is elementary event, or it can be also called simple event. So simple event means the outcome of an experiment is called simple event. Okay? Suppose here you see, if you give various examples for random experiments, tossing coin, throwing die, drawing cards or balls, so from what it may be, etc., etc., etc. These all are random experiments. Elementary event means the outcome of the random experiment is said to be elementary event, or the direct result of the random experiment is said to be elementary event. For example, if you toss a coin getting head when you toss a coin, this is elementary event. Okay, if you throw a die getting the number 2 when you throw a die, it is an elementary event. So these direct outcomes of the experiments are called elementary events. Next, event. Our next definition is event. Event means the collection of some elementary events is known as event. So the collection of some elementary events or the collection of some simple events is known as event. For example, if you throw a die, suppose you getting even number would be event. Why so? Because it is collection of 2, 4 and 6. It is a collection of various elementary events, various simple events. Because it is a collection of various simple events, so getting even number would be event. Suppose if you draw a card from a pack of cards, okay, getting red card is an event, because overall in pack of cards there will be 26 red cards. So getting red card is the collection of 26 elementary events. So it is called event. Understood? See, dear students, our next discussion is equally likely outcomes. See, in a random experiment, okay, if there is no reason for you to expect one outcome in preference of the other outcomes, then all those outcomes are said to be equally likely events. For example, if you roll a die, how much there is possibility to get 1 on the face of the die, the same possibility is there to get any of the 6 numbers on the face. So all these numbers are equally likely outcomes. Similarly, if you toss a die, okay, if you toss a coin, okay, how much possibility is there to get head on the face, the same possibility is there for you to get tail on the face. So you cannot give any preference to head or tail, okay, comparing to the another one, okay. So a head or tail having equal possibility to occur on the face of the coin. So these are called equally likely outcomes. Did you understand? Next, mutually exclusive outcomes. mutually exclusive outcomes. See, in an experiment, such outcomes are said to be mutually exclusive outcomes if there is no possibility to occur two outcomes at a time. Almost in every experiment, all outcomes are mutually exclusive outcomes only, because if you toss a coin on the face, if you have seen head, anyhow you cannot see tail in the same trail. Understood? Suppose if you throw a die, suppose you got the number 5 on the face of the die, in the same trail you cannot see 6. Okay, so in any random experiment, all outcomes are, I am saying outcomes, not events. Okay, I am talking about, okay, elementary events, simple events I am talking. Events, that is secondary. There may be some mutually exclusive events, there may not be mutually exclusive events, but as far as outcomes are concerned, all outcomes in any random experiment are mutually exclusive outcomes only, and all outcomes okay, in any random experiment are equally likely only, and moreover we only entertain equally likely outcomes and mutually exclusive outcomes to define the word probability. So it is by default you can take it as granted that in a random experiment all the outcomes are mutually exclusive outcomes and equally likely outcomes. So mutually exclusive outcomes means no two outcomes can occur in the same trial, in the same experiment, in the same trial. See, you have performed tossing coin, head and tail, both can you see, both can you see at a time? Never. So this kind of outcomes are said to be mutually exclusive outcomes, and as I already mentioned that important note, whatever the experiment we take in probability are random experiments, and whatever outcomes you get in the random experiment all are mutually exclusive and equally likely, whether it is stated or not stated. Particularly it is understood, okay, you have to consider. Okay, next, exhaustive cases. Exhaustive cases means all possible outcomes in a random experiment. Suppose if you toss a coin, so all possible outcomes, number of possible outcomes are 2, HT. So these are called exhaustive cases. Suppose if you throw a die, cubical die, so here exhaustive cases HT, total their number is 2. Here exhaustive cases 1, 2, 3, 4, 5, 6. Their number is 6. Suppose if you take pack of cards, okay, so there will be 52 elementary cases, we cannot write them. So 52, their number is 52. Exhaustive cases number is 52. So that exhaustive number of cases, okay, differs from experiment to experiment. Understood? Next, favorable outcomes. Favorable outcomes means in an experiment, okay, there are certain outcomes which respond favorably in happening of the given event. Suppose say the given event is getting a tail in tossing a coin. So the favorable case is 1, that is T. So one favorable case is there, that is T. Suppose in rolling a die, suppose the mentioned event is getting even number. The mentioned event is getting even number. So there are 3 favorable cases, 2, 4, 6. 2, 4, 6. These are favorable outcomes for this event, getting even number. And their number, how many favorable cases are there means there are 3 favorable cases. So like this, favorable case number, okay, differs from trial to trial, event to event. Okay. Now we are defining the term probability. It is a mathematical definition of probability. See, I am defining word probability. If a random experiment results in n number of exhaustive cases in which all cases are equally likely and mutually exclusive, in which m number of cases are favorable to the occurrence of a mentioned event E, then the probability of event E is denoted by P of E, and it is defined as P of E is equal to m by n. M by n means favorable number of cases by exhaustive number of cases. So here one point you have to understand, every student should understand, the favorable number of cases can never be greater than exhaustive number of cases, because after all they are collected from them. We are picking up from exhaustive number of cases. We are picking some of the outcomes from exhaustive cases which are in favor of E. So favorable number of cases cannot exceed exhaustive number of cases. So here one note you have to understand that m is always lesser than, in some cases may be equal to n. So m is always lesser than n or equal to n, but m can never be greater than n. Understood? Next, m belongs to whole numbers, because sometimes m can be 0. In some case, in some events, there may not be even one favorable case. For example, if you throw a die, what is the probability to get a prime number greater than 7? If it is the event, so no prime number greater than 7, greater than 6, say you can see greater than 6. So if the event is in tossing a die, getting a prime number greater than 6, suppose it is a mentioned event. So maximum 6 numbers will be there. So how you can get a prime number more than 6 when you toss a die? So in such cases, m would be equal to 0. So in some cases, depending on the events, m can be 0. So m belongs to whole numbers, and always n is a positive integer. N cannot be 0. If n is 0, there is no experiment performed. When there is no experiment performed, no expecting any outcomes or events or probabilities. So n is always positive integer, m is lesser than or equal to n. Combining these two facts, you can come to a conclusion that always the probability of an event exceeds 0 and it is below 1 or equal to 1, and it may be equal to 0 also sometimes. So the strict limits for probability of an event, the strict limits for probability of an event are 0 is lesser than or equal to P of E is lesser than or equal to 1. Understood? So coming to our next definition, complementary event. Complementary event means the non-occurrence of event E, that is not E, is known as complementary event. Not E is said to be complementary event. Symbolically it is denoted by E complement. So how the probability of E complement can be defined? Probability of E complement is equal to n minus m by n, because for E there are m favorable cases, so obviously n minus m cases are favorable to not E. So n minus m by n, which is n by n minus m by n, which is equal to 1 minus m by n. So P of E complement is equal 1 minus m by n, which is 1 minus m by n means P of E. So this is the most popular relation, useful relation throughout the chapter. Probability that P of E complement is equal 1 minus P of E, or you can even say P of E plus P of E complement is equal to 1. Understood? So now let us take some examples, some example problems basing on definition of probability. I am not writing the question, just I am reading the question. When two dice are rolled, what is the probability to get a doublet on the face? So when two dice are rolled, you get a total number of exhaustive cases 36, because you have thrown two dice, 6 into 6, 36 exhaustive cases you get. And getting a doublet on the face is saying, doublet means getting same number on the face, 1 1 2 2 3 3 like that. So how many doublets would be there? 6 doublets would be there. So this is m value. Therefore what is the required probability? This is equal to m by n, equal 6 by 36, which is 1 by 6. So this is the central idea of a probability. Go to any problem, it may be relating to cards, it may be relating to balls, or it may be relating to dice, coins. The central idea is same. You have to see what experiment you are performing and what is the event is under discussion. Then you have to collect the exhaustive number of cases in that performed experiment, and you have to take a favorable number of cases for the mentioned event, and then you have to write the probability of E, which is equal to m by n. Understood?